Well, I also want to start showing you our website, because in our website, in this part, in the KNX product, you can find a lot of information about our product, a lot of technical information. For example, we will go to the actuators. We will find the complete range of actuators. And if you go into one of the actuators, for example, this one, you will find the datasheet, the programming manual, the ETS catalog, and also a document with frequent questions and answers. Well, in the programming manual, you will find a description of all the parameters and all the communication of it. So in this webinar, I will try to explain a bit the parameters, but if you need more information, you can find it in this programming manual. Okay. Well, we come back and, well, this is the complete range of actuators that we have in BES. We have the multifunctional ones that has a power cut of 16 amps in each relay. And we have the 4 inputs one, 2 inputs, 2 outputs, 3 inputs, 2 outputs. That all of these actuators have this size, the small size. And then we have the 6 inputs, 4 outputs, 9 outputs, 16 outputs, and 22 outputs. That all of them are DIN rail mounted, and they have the possibility to be with the manual control in the device. With this manual control, you can act on the different relays only by pressing this button without any programming. So it's very useful for installation purposes when you are connecting something. To assure that you connect it in the right relay, you can act with this manual control. We also have some actuators that are for specific functions. These are the 7 outputs actuator, that is for controlling motorized wires, and the 4 inputs, 4 outputs actuator that are for controlling low voltage signals. For example, low voltage LEDs. All the actuators have a arithmetic logic unit and timers and counters. I will explain this part when we see it in the ETS. And about the multifunctional actuators, why do we call them multifunctional? Because in all of these actuators, you can set the configuration for a binary output, for a shutter, for a fan coil, or a bulb. And you can have all these functions in the same actuator. So in the same actuator, you can set a binary output, a shutter, and a fan coil. Everything in the same actuator. Well, we will move now to the ETS, and I will show you all of this. So this is the ETS, and this is the actuator catalog. We will do a brief view of all the parameters, and then we will move to make some examples. Well, in this first tab, it's the general configuration. You can choose the hardware type, the actuator that you are using, and if you want to activate the advanced functions. Well, we will see that functions later. For example, in this one, we will choose, with inputs and outputs to see everything. 6 inputs, 4 outputs. You will have the inputs configuration and the output configuration. In the input configuration, you can choose how do you want the inputs to send the telegrams. If you want to send a telegram when the input closes or opens, or if you want to differentiate between a short press, a short contact in the input, or a long contact. So, for example, we will set the short long for the input 1 and the open close for the input 2. If we go to the input 1, you will see that you can make an action, you can send a telegram when there is a short contact in the input 1, and you also have the long action, the long contact in the input to send another telegram. If we go to a simple open-close input, you will have the option to send a telegram when the input closes, send a telegram when the input opens, or send a telegram when the input opens and when the input closes. Which telegrams can we send in each of these configurations? Pues we will go to the short press action, for example. You can switch between on and off. That means that first time it will send on telegram, and second time it will send an off telegram. So it will be switching between on and off telegrams. You can also send a value, that's a 1 byte value between 0 and 255. You can also make a dimming for a light to increase or decrease a light, or also a speed or what you want. It's a percentage. And you select also the step for that increase or decrease. You can control directly a shutter or a blind by stopping it with a short press or moving it with a short press, what you want, up, down. And you can activate or learn a scene. That's what you can send. That's the telegrams that you can send with any of these different contacts in the inputs. Short contact, long contact, you have also the same telegrams. And with the open close, we will set, for example, open, you have also these different options to send telegrams. And that's all about inputs. With the different configurations that you set here, for example, in input 1, we have short or long. So in the communication object, the input 1, you will find a communication object for the short press and another communication object for the long press. If we set in only open close, you will only find in the input 1 one unique communication object. So we will move now to the outputs. Okay, we will, for example, put the 16 outputs actuator, and we have all the output configuration. As I told you, you can have binary output, you can have bulbs, you can have shutters, and you can have Fancoils, all of them in the same actuator. So in this big actuator, the 16 outputs 1 or the 22 outputs 1, you can have many different functions. You can have almost a small house in only one actuator. All the functions of a small house in only one actuator. Okay, so now we will move to see the parameters of each type of output. In the binary output, well, you can choose between normally open or normally closed relay. Well, to open it, to close it with our on Telegram and open it with off Telegram, or open it with a on Telegram and close it with an off Telegram. You can also choose the status after a voltage recovery. That means when there is a power cut and then the tension comes again, you can choose the status of that relay if you want it to be open, closed, or without changes. You have also the possibility to lock the relay. And well, when the relay is locked, you cannot act on it, but you can choose the behavior when you lock it. I mean, do you want to lock it because there is a fire alarm or something? You can choose to open it, to close it, and then you can choose the behavior when you unlock it because, well, the fire alarm goes off and you want to have the last status before lock. You want to open or close it, or you want to update it. That means that if when it's locked, you change the status, you open or close it, but it doesn't really opens or closes because it's locked, but it has received that order. So when you unlock it, it updates the status with the last order that you have sent. Then the scenes. Well, about the scenes, we will make an example later, but you can configure up to 16 scenes for all the different outputs. And you can choose the scene number, the output value that you want to show in when the scene is activated. You can configure a delay. You can also activate the learn mode, that is to allow the final user to change the status in the different scenes. You also have timers. We will also make an example with the timers of the outputs. Well, to make delays in the turn on of the relay. You can also make staircase timers. You can make delays in the off. Well, many things with the timers. Well, this part that is statistics about how many times has the relay have been opened, or or the running hours. You can set an alarm with and it's up to 1,000, for example, hours. It goes out of that hours. You can set an alarm. Okay. Then with a valve, it's almost the same configuration, but the only different thing is that you can set a PWM control to control a valve. Sometimes you don't only need the on-off control, you also need the PWM control, so it allows you to make that. The other things are almost the same. Then we will go to a shutter. Let me configure this as a shutter. Okay. In a shutter, you have a shutter with slats or without slats. And you have to configure the different times to put the position of the shutter correctly. You have to measure the travel time up and the travel time down to make that when you send I want the shutter to 50%, to have a correct 50%, to be in the middle of the window or the door. So you need to measure that times to put the correct position of the shutter. Well, that times are to adjust that times, and also to, well, this one, the direction change pause, is the time in the change between the shutter moving up and the shutter moving down. When it's moving up and you change to move down the shutter, it makes a little pause to, well, it's to protect the engine. You can have the status feedback during the movement. That means that it will send to the, well, the actuator will send to the bus the status of the shutter every second. So you are moving down the shutter, and in the bus you will see that it's going like 50%, 52%, 60%, 65%. Every second it will update the actual position. There is also a communication object to show if the shutter is going up or down. I will show you in the shutter line. This one to show if it's going up or going down. Also the status after voltage recovery, and the log and log the scenes in the binary output. And well, finally the Fancoil, where you have the possibility to configure a direct Fancoil or a sequential one. Well, a direct Fancoil, you know, Fancoils have 3 different speeds: low, medium, and high speed. So in the direct Fancoil, when you select the speed number 2, only the relay 2 will be closed. Relays 1 and 3 will remain open. And when you select speed 3, relays 1 and 2 will remain open, and relay 3 will be closed. If you select the sequential, if you are using a sequential Fancoil, when you select the speed 2, both relays 1 and 2 will be closed. Only the relay 3 will remain open. And when you select speed 3, the 3 relays will be closed. So that's the difference between direct Fancoil and a sequential one. You can also select the different thresholds to activate one or other speed. In this case, for example, from 0 to 10%, the Fancoil will be off. From 10% to 40%, it will activate the speed 1. From 40 to 60%, it will activate the speed 2. And from 70% to 100%, it will activate speed 3. You can also select the hysteresis that you want, and you can allow it or not the manual function. Normally...
Sorry, Andres, there's a question from Kumar in the chat that maybe you can clarify right now, because as we are talking about the Fancoil, maybe it's the time to clarify.
Which question?
Where is 0, how to make it off the fan?
Well, when it's working now, we have the manual function deactivated. So, well, let me go to the communication objects. So with that configuration, it will work automatically from a controller, from a thermostat. So to make it work automatically without manual function, you need to have a thermostat or to have a temperature controller to give the orders to the Fancoil. So No, object 107, it's only, you cannot write on it. It's only a transmission object. So you cannot write. It's only to inform you about the status of the fan coil. You only control the fan coil in this case with this object. In this object, the actuator will receive a percentage. That percentage will be sent through a thermostat. Well, a thermostat will send that percentage. So if you want to turn off the fan coil, you will need to turn off the thermostat or to put in the thermostat a set point. Well, it depends if it's a fan coil for cold or for hot. But you only can turn off the fan coil using the thermostat because now it's working automatically. So it will only receive the orders from the thermostat. If you want to act manually on the fan coil independent from a thermostat, you have to activate the manual function. So if you enable this option, well, you can choose if you want the manual to activate the manual with a 1 or with a 0, and if you want individual speed objects, or well, only one object to increase or decrease the speed. Now you have the automatic and manual, and you can turn on or off in this object in which you can write. You can, well, turn on or turn off the different speeds. If you turn off all the speeds, if you put here a 0, it will turn off the fan coil. And in that object, you can write to set the different speeds manually. Okay. The regular way to make the, well, we will make a configuration of a fan coil in one of the examples. The normal way is to have both options, the manual controlling and also the automatic controlling through a thermostat. We will make an example later and you will see it. Well, status after voltage recovery, delays, lock and lock, and scenes as in the other outputs. I think it's better to move to the examples. All these parameters, all these communication objects, you can find the description in the programming manuals in the website. I think that you will see better all of these parameters and I will explain myself better with the examples. So we will move to the examples and I think you will understand everything better. So, well, I put 5 different examples to show you everything, and then if you want me to make something else, you can write it on the chat and I will try to make it. Example 1, turn on a light from an input, and we want the light to turn off automatically after, well, 30 seconds or 10 seconds or whatever. So we will go to an actuator. I prepare this one. In this actuator, well, 2 inputs, 2 outputs actuator is enough for us because we only have to control one light. So we only need one output and one input to turn it on. Okay, what do we need in the input? We don't really need a short, long push button. With open close, it's enough to every time we close the contact, we can send a telegram to turn on the light. So with open close is enough for us. And here we want that every time we close the input, every time there is a contact in the input, we want to send a 1. to turn on the light. We don't need to switch between 1 and 0 because we will send a 1, the light will turn on, and we only want to turn off we want the light to turn off automatically, not with the button. So we will send only a 1. Okay. So we have now in the group objects, let me input 1. We will link it a new address 001 that is push button. Okay. Now we need to turn on the light, and we need to have the light on only for 30 seconds, and then the light will turn off automatically. So we need a timer. We need to set a timer to count that 30 seconds and turn off the light. So we don't need to lock or unlock. We don't need the scenes for now. We don't need the statics. We need the timer. So you go to the timer configuration. What do we need? We need a staircase timer. We need that when we send a 1, the light turn on, and then it starts the count. It starts to count 30 seconds, and after that 30 seconds, we need to turn off the light. So we will set a staircase timer. Which staircase time do we have to set? 30 seconds. This option is to, if we enable this option, every time we send a 1, the count will restart. We will have again 30 seconds. If we turn on the light, we press the button, it turns on the light, and it starts to count the 30 seconds. If we press again the button, it will restart counting the 30 seconds. So we will enable it. And allow manual off means that maybe you have another button from which you can you want to turn off the bulb without the 30 seconds wait. So if you allowed to turn off the bulb manually, you will be able to do that. If you don't allow the manual off, the light will only turn off after the 30 seconds. You will not be able to turn it off from another button or from another point of the bus, the KNX bus. So we will leave it like this. And now in the group objects, we have to link our push button with the timer staircase. So we'll link it, and we have it. We don't need to do nothing else. When we press this button, when we close the input 1, it will send a 1 through this group address, the 001, and it will turn on the light and start the count. After the 30 seconds in the count, it will turn off the light. It will open the relay. If during the count we press again the button, it will restart the count. So that's our first example to show you the timers. Okay. Of course, we can do more things with the timers. You can put a delay in the on. You can put a delay in the off. Well, there are many different timers, but this is one of the most common examples. Okay, so we will move move to the next example.
Andres, before to change to the second example, there are some questions from the people about the binary inputs. It's also important to add or to clarify that we can use those digital inputs not only for push buttons or to control manually the lighting or whatever. We can use also those digital inputs, for example, to connect the conventional sensors we have in our catalog. I'm talking about the fluid sensor, the fire sensor, and the movement sensor. As you know, in our catalog, we have the KNX sensors, but we also have conventional sensors. So those conventional sensors, you can connect to the digital inputs, and you can use them to detect any technical alarm you consider, and we can exchange that detection to a KNX telegram. So it's also important to clarify that digital inputs can be used for push buttons or also for conventional sensors that you can find in our catalog.
Yeah, well, they are low voltage inputs, so you can connect any sensor, any conventional sensor, or push button to make that contact. Well, at the end, it's only it detects the close of the input. I mean the union between the input and a reference. So if there is any sensor that close the path of the current between the input and the reference, it will detect it, and it will send the telegrams that you want through the KNX path.
Mm-hmm. Exactly. And Andres, I don't know if you are gonna go deeply on the timers in the next examples, but I think for the people it could be really interesting to go ahead more deep on the timers. So if you want to explain something else in the next examples, feel free to explain to the people. Okay.
I will finish with the examples, and
okay,
then
sure.
And then we can move and see.
Okay, great.
The timers. Okay, a shutter. How to configure a shutter? Well, you need to measure the travel time up and the travel time down in the shutter, and then you go to the actuator. 2 inputs, 2 outputs is okay because a shutter needs 2 outputs, one for each direction, the engine. And in the regular way to configure a shutter is to set short to long push button in the inputs. Why? Because we will use the short press to stop the shutter and the long press to move the shutter. One button to move it up and the other button to move it down. So, well, I said the short long for both inputs. And in the input one, the short press, we will set shutter blind, and we want to stop the shutter. It doesn't mind if you put here up, down, or up, down. Doesn't matter. And in the other one, in the long press action, we want to move the shutter. So we will move it, for example, in this one, we will move it down. And the long press time is the difference between it's the time that you have to press the button, that you have to close the input to have a long press. I used to set 1 second, but maybe half second is enough. I don't know. I used to set 1 second. Well, in the other one, for the short press, we want the same. We want to stop the shutter, and in the long press action, we want to move it in the other direction. So here we put down. So now we will put up. So 1 second, and we have the inputs for the shutter, and in the outputs we set shutter The times, we don't know the time now, but you have to hear the different times, the travel time up and the travel time down. In the direction post, I used to also to have 1 second. And the additional time for adjustment might be used to put it 5 seconds. It's not really important to have a long time here. This ones doesn't matter. I mean, status feedback on movement. Well, you can enable it or not if you want to have the status every second. But if you don't enable this option, you will have the status at the end of the movement. So for me, it's enough. So here we have the short press actions, the long press to move it down, and the long press to move it up. And here in the outputs communication objects, we have the communication object to move it, the communication object to stop it, and then position and the position status communication object. So we will link is the stop action. We have it in both short press inputs, and we want to link it with the stop of the communication object in the output. And the movement, we have in the input 2, we also have the move action, and we have to link it with the move action in the communication object of the output. These ones are to control the shutter directly sending a percentage. You send a 50%, for example, to this communication object, and the shutter will move to be at 50%. So this is the position. And through this communication object, you will have the position status. It will inform you about the position status. These ones are useful especially for when you have a screen or when you control the shutter from an app or with Google Home or with our app. In the apps, normally the control of the shutters is with the position, and it's not only moving the shutters up and down. You set the position that you want in the shutter. Okay, so in the next example, we will configure a scene with the light and the shutter. Okay. We have here the light that we previously configured, and the shutter is here. So if we go to the outputs to the shutter output configuration, and we activate, we enable the scene option. Well, we will only need one scene. We will set the scene number 1, and which position do we want in the scene? Well, I think I put 20%. Okay. So we set the position that we want in the scene, and when we activate the scene 1, that shutter will move to 20%. You can activate or deactivate the learn mode. The learn mode is to allow to change through the KNX bus the value of the scene. I mean that value. So if you activate the learn mode, you can change the the value in the scene. I will show you, we will do the same from the light, and we'll show you how to change that value. Okay, in the light, if we activate the scene number 1 also, the output value for that scene will be on, and we also activate the learn mode. Okay, so we will activate that scene, for example, from this input number 2. When the input closes, we will send a scene value, and we can activate or learn. In this case, we will activate the scene number. So with the input 2, we link it with the scene activate learn of the, with this communication object in the actuator, and also with the scene activate learn in the shutter, in the other actuator in which we have the shutter. So now when we act on this input, when we press the button that is connected to the input 2, we will activate the scene number 1, because in the input 2 we activate the input 1. So the light will turn on, and the shutter will move to 20%. Now, if we set for example, in the input 2, no, not in this one, in the input 2, we activate the scene with a short press. But if we make the input short and long, and with the short press we activate the scene number 1, and with the long press we also send a scene, but we send a learn action for the number 1. When we make a long press in that input 2, it will send a learn telegram for a scene 1. So it will, the actuator will record the status of all the different relays in that scene. So if the shutter is at 50%, and you make a long press on input 2, it will learn that now the scene 1 is with the shutter at 50%. It will record the status of the shutter to set it in the scene number 1. So if you come back to activate that scene, now the status of the scene will be 50% instead of 20%. Okay, that's about the scenes. About the Fancoil. Okay, if you don't want the manual control, as I explained before, you need a thermostat to control the Fancoil, because you need a thermostat to send orders to the actuator to choose between the different speeds. So we will go to a Fancoil. Let me configure it. For example. So in this fan speed control, we will link it with the thermostat. The thermostat will give us a 1 byte value, a percentage, to control the fan coil. In this, we will have status, and these ones are to know if we are speed 2 and fan speed 3. In which speed are we now? And this one, it's only a transmission object. We cannot act on this. This is only to inform us about the status of the fan coil, if it's on or if it's off. So it's on, off, but it is only a status. So if you want to turn off the fan coil, you need to turn off the thermostat. So the thermostat will send a 0 here, will send a 0% in the control. And if we receive a 0 here, the speed will be also 0. So the fan coil will turn off. If we want to set a manual function, with a 1 we activate the manual. Through that communication object, we can change between the automatical function or the manual function. Okay, this is auto or manual. We will receive the status through this communication object. And we can change the speeds in this communication object. These ones are only transmission communication object, but these ones, you can write on them, you can act on them. So if you send a 1 to this, for example, to this communication object, you will set the fan speed 2. And with this one, you can turn on or off the fan coil manually. If you send a 1, you will turn it on, and if you send a 0, you will turn it off. Okay, so this is how to configure a fan coil. And last example are to show you the advanced functions. Well, only a bit because there are many things to tell about the advanced functions, but we will see. Okay, in the general tab, if you go to the
Andres,
yeah.
Just a second before the to change to the latest example. Laurencio has done a question about if we can use the status on off to open close a valve. So maybe it's
open close a valve. Yeah. Let me show you. Okay, where is the fan coil? Yeah, here. Okay, for example, we set a valve here. Set a valve here. Okay. Okay, you have the valve in the output 4, and with the status of this one, if you link it directly with the control of the valve, with the communication object in which you can write, you can act on the relay of the valve, you will control the valve. When the fan coil is on, you will receive a 1 through this group address 0012. So the valve will close, and when the fan coil is off, you will receive a 0. So the valve will open. So you can, it's the normal, the most usual way to configure a fan coil is this way, because, all the fan coils have the fan, you control the 3 speeds of the fan, and then you have a valve to close or open the air, the air entrance. So this is the most usual way to configure a fan coil. with a valve that opens or closes depending on if the fan coil is on or off. More questions, Miguel?
Yes, there is another question from Keita. I'm gonna copy it in the chat so you can see it again.
Let me open the chat.
That was the question that Keita done before.
Let me just keep going. So Keita is asking that if we activate a scene, how the timers will work with that scene. Well, as I told you here, there are different communication objects for the timers and to turn on or off the light directly. So if you activate a scene, the timers will not work with that screen. So the light will remain on. I mean, with that timers, the light will remain on until you press a button or do something to send an off order. Well, as I will show you now, there are advanced functions. Let me show you here. Okay, if you activate the advanced functions, you will also have timers and counters. Well, you have arithmetic logic unit and you have timers and counters. So maybe if you want to activate the light with a scene and then you want to turn it off automatically after a time, you can set a timer here. Okay, timer, limit timer, a constant value of 30 seconds, and activate that timer each time the light turns on. So if you turn on the light from a scene, I will make that example because I think it's interesting. Okay, so imagine we have here 2 inputs, 2 outputs, and in the channel 1 we have a light. Okay, we connect in the output 1 a light, and we want to turn it on with a scene. For example, scene 1. Scenes. In the scene 1, we turn it on. Okay, and we set a timer for 30 seconds. So we activate the light here. Okay, and we want to turn off the light after 30 seconds. So, well, this is to turn on off the light directly. Here we have the status. Okay, so we can set the status to enable the timer. So every time the light turns on, it will enable the timer and this timer will start to count. And with that, with the output of the timer, we can link it to turn off the light. So if we want to turn on well, there are many ways to set the timer, but if we want to work with a scene to activate the light, and then we want to the light to automatically turn off, we need to set the timers in the advanced functions. That's the way to do it.
Perfect, Andres. I think another important thing could be to explain the people about the delays, especially when you are managing a fan coil and you want a small delay between cooling and heating, especially to avoid damages in the fan coil. So maybe you can explain a little bit about the delays.
Yeah. Okay. Delays in the fan coil. Okay. You can set, well, we go to the fan coil output. We enable the delays option, and you can activate. Well, we can set 3 different times. The first one is a delay in the switch of the different speeds. I mean, you are in speed 1, now you need to activate the speed 2, so it will take that time to change between one speed and the other. So for example, in the change from speed 1 to speed 2, it will open the first relay, it will take this time, and then it will close the second relay. These delays are the delay in the on. That's what Miguel is telling. I mean, when you are in the cool mode of the fan coil and it's working, and then you change to the warm mode of the fan coil. You can put a delay here, and as the fan coil will pass from the speed, for example, 2 to speed 0, and then starts with other speed in the other mode, in the cool or the warm mode. You can set, for example, a minute here, and it will take a minute to restart the fan coil in the new mode. You can also put a delay in the off, so if you are changing from cool mode to warm mode, you will have 2 minutes between one and the other, because it will take a minute to turn off the fan coil in one of the modes, and then it will restart in the other mode, and it will take a minute to start it. So with that delays, you can manage these changes.
Perfect. Another pending question we have is from Kumar. He's asking about a 0 to 10 volts bulb. In case we have a 0 to 10 volts bulb, we have another module with 4 0 to 10 volts channels. So you can manage on that way. And Andres, if you want, you can explain about the byte object to control in proportional way.
Yeah, well, to control proportionally the fan coil, you mean?
The bulb.
A bulb, okay.
In case we want to use a 0 to 10 volts bulb.
Well, but if you want a 0 to 10 volts, well, you can use the 0 to 10 model that you are explaining.
Yes.
Or maybe you can do it with the PWM control in the actuator. Well, 0 to 10, it's better to make it with the other model, but maybe with if you have a power supply, and well, the PWM control is to close and open very fast the outputs. So maybe closing and opening the output, you can get a signal. Well, it's better to use the other module, but you can do it that well. Do you want me to explain him with the dimmer, the 0 to 10 dimmer? I mean,
okay, if you want, you can go ahead with the latest example, and then we can clarify to Kumar about the 0 to 10 volts device.
Yeah, I think it's better to explain to him directly.
Okay.
not here because it's not with the actuator. I mean, it's with other module.
Okay, clear.
So
yeah, you can go ahead with the latest example.
Yeah, the latest example is to show you the logical gates, the arithmetic logic unit. And for example, we will make, well, we will have 4 lights, and we want to turn on this light, well, I don't know if you are seeing the mouse, but we want to turn on a light when one of the other lights is on. So at the time we have one of the lights on, we want to turn on the other light, okay? So that's how an OR gate works. If in an OR gate, if there is a 1 in one of the inputs, in the input A, B, C, well, you can have many inputs. If there is a 1 in one of the inputs, you will have a 1 in the output. So if we have here for the gate, well, I will do it here. Okay. Choose, for example, this one. We have in the outputs, we have all binary outputs. We have activate this. Activate the advanced function. So we have one status, 2, status, and light 3. With the status. Okay, and we want to control this relay, this light, depending on the status of this light. 1, 2, and 3. So we want that when one of the lights, the 1, the 2, the 3, all of them are on, we want to turn on the 4th light. So we will use the advanced functions. We will set one of the blocks, and in that blocks, you have many different logical gates. All of that gates are described in the programming manuals. Okay, I will do this example with the OR gate because we need that behavior, that when one of the lights are on, when we have a on in one of the inputs, we need a 1 in the output. So I will set an OR gate. We need 3 inputs, all of them with communication out here, and well, an output, all of them with one bit. You can, well, this is a very powerful tool. So you have 1 byte, 2 bytes, everything to put in the inputs or also in the output. For now, we only need 1 bit inputs and outputs. So we will put the status of the different lights in the inputs and link the output with the light number 4. So now, when, for example, we turn on the light 1, we will receive a 1 with in the status. It will go to the logical gate, and as we have a 1 if one in one of the inputs, we will have a 1 also in the output. So it will turn on the light number 4. That's the OR gate. Okay, and that's all about the examples. So let's go ahead with the questions.
Well, I think more or less we have been clarifying all questions in real time. So I don't know if you want to share any other question in the chat. In case, feel free. Let's wait for 5 minutes or so, so we can clarify in these 5 minutes. It's 11:13 at this moment. It has been more than 1 hour. I think has been really interesting and really productive. But in case you want to ask any final question, feel free to text it in the chat, and we can clarify within all of us.
And you can also write to our mail if you prefer to speak directly with me or with our technical team about some concrete.
There is a question about how many inputs are supported in the logical unit.
You can set up to 4 inputs in each block. You have 8 different blocks, and in each block you can set up to 4 inputs.
Yeah, another question is about if we can use the actuator for room divider control. Well, it depends on what kind of motor you have. You should use one actuator or other. In case we are talking about 230, 110 or 230 motor, we should use a free potential relay. So we must go ahead with the 16 amps cutoff capacity actuators. In case we are using a 12 or 24 volts signal or motor, we can go ahead also with the 7SK, the actuator for the low voltage motors. Maybe I don't know if because most of you are asking me about the arithmetical functions. Maybe we can dedicate a couple of minutes, Andres, to explain a little bit more, because it's quite interesting for the people. Yeah, Andres, can you hear me?
Yeah. Sorry, can you repeat?
Yeah, I think that for the people, the arithmetical unit is quite interesting. So maybe you can explain a little bit more to the people.
Well, we can make some other examples. I mean, there is a lot of information here, and you can do many things. It's a very powerful tool. Maybe we can do another example, but I think that they need some time to work with the logical gates, and then they will have more questions about all this, because when you see someone configuring the logical gate, it seems really easy. But then when you start to make different things, or you want to make some difficult things.
Well, I have seen many questions about the arithmetic. I have seen a lot of questions about the arithmetical logical unit. So maybe we can organize at the end of this period another seminar to explain in detail about the logical unit, because this is a huge world.
We can go one by one with all the different logical gates.
So yeah, maybe it's better to prepare a complete webinar about the logical unit, and we can explain in detail, very deep, about the functionality and the potential of that tool. Because I'm seeing another questions like, can we have one input to 2 outputs logics or things like that? So I think we can clarify about the logical unit in another webinar more deep.
I think it's better, because it's a lot of information to to give that information now
in case you need, someone of you need some urgent support on the logical arithmetical unit, feel free to send us an email and we will clarify in advance. If not, sure, we will organize for sure a logical seminar for sure. Okay, so here you have the technical department information. I think it has been enough for today about the actuators. In case you have any questions, as we have told you, feel free to share with us your doubts. And hope this seminar has been useful for you. Many thanks to Andres for the explanations. And thanks a lot to all the people who has joined us here today to the seminar. Hope to see you in the next seminars, and the idea is to do this time at home more productive for all of us. Okay, so thank you so much for your cooperation, and take care with this strange situation we are living, and hope we can communicate along next seminars. Okay, so thank you so much, and for sure feel free to share the links and the information with most of people you want. Okay, take care, and thank you so much for everything. Bye-bye.